Good day, everyone. So I'm here to continue the acid-base concept. In my previous video on acid-base concepts, I discussed the acid-base theory or concepts, the three basic concepts based on the current use, which is Arrhenius, Bronsted-Lowry concept, and Lewis concept. And after that, we discuss the strength of the acid and base, which simply means what the tendency of acid and base to want to ionize in solution and lead us to the weak acid and the strong acid. Likewise for base. And from there, we'll discuss the physical and the chemical properties of what of acid and base. Then how are we going to prepare acid in laboratory by using direct combination of constituent elements. And this next one, after that, we'll discuss the pH of what? Of an acid. So, where pH as an acid as a negative logarithm of concentration of hydrogen ion to base 10, which is expressed in mole per dm³. Likewise, for what? For base. And then we also discuss the pH of a weak what? Weak acid and a weak base by using Oswald dilution law, which is the one that is what help us to understand the behavior of weak electrolyte, which is weak acid and a weak base in the what? In the solution. And I will solve numerous questions on it. So in today's class, under acid-base titration, so we are going to treat what? Buffer solution, then a calculation on pH of buffer solution. Then we are done with that. If we are done with it, we are going to treat what? Acid-base titration. So if you can treat the two, like we are done with what? Acid-base concepts. So let us move to the buffer solution. So what is buffer? See, buffer is a solution which resists change in pH when small acid or base is added to what? To it. Take for instance now, assume we have a what? We have a beaker A and we have another beaker B and we have another what? Beaker C. Look at what? This A, assume this is what? The solution we have in what? In it. Let me call it what? Beaker what? A. And this one A, we have what? Beaker B. This is what? B. Let me take my second marker, the green marker. So this is what? Beaker what? Beaker D. C. So please let us look up here. You have A, B, C. Let me write the words. They are this thing here. Sorry. Call this one what? A. This is B. This is what? C. And on top here, we have, hmm, let me say, yes, yes. Think that what? We have acid here. This is, we have acid here. And we also have what? Acid here. We also have what? Acid what? Here. Good. Before introduce this acid into the beaker A, beaker B, beaker C, assume that what? No, let me put uh, A, B, C. Immediately you add what? Acid into this what? Beaker A. What happened to it? The color of what? Of this beaker change. Color what? Color change. When acid is being added to it, what happens to color? The color change. Then the pH of this beaker A also what? Change. What do I mean by this statement? The initial color of A before adding acid, immediately you add acid to what? To the beaker A, the color change and the pH also what? Change. The same thing to what? To B. Then you add what? Acid to this beaker B, color of what? Of this B change and the pH of what? Of this B also what? Change. You know, we have some substance that maybe if their pH before is 2, if assume that what? The pH for this one before adding, the pH is what? Assume is what? Is 2. If you now add what? Acid to it, the pH change to, and the pH change to what? To 4. So assume the pH for this man B before adding what? Acid to it. Assume the pH of this man before is what? Is 11. By the time you add acid to it, maybe the pH is what? Change to what? To 8. You can say that what? In presence of acid in these two solutions, their color change and their what? Their pH also what? Change. Abi? Yes, but in this thing what? See, yeah. When you add what? Acid into this solution, what? See, the color, the what? The color is not what? Change. And the pH also what? Not change. So out of this what? This three solution we have, ABC, the only C that is what? In the presence of acid or base, the pH remain and the color is also what? Remain. So the tendency of what? Of this C should resist the change in pH when acid is being added to it. And therefore, this what? B, C is called Bover solution. It's called what? Bover solution. What is Bover solution? It's any solution that resists the change in pH or color when small acid or base is being added to it. Is called Bover solution. So this solution A and solution B, they are not Bover. because in the presence of acid change their color and it's also change their what? Their pH. So buffer solution now. Buffer is a solution which resists change in pH when small acid or base is added to what? To heat. That is buffer. Any solution that resists change in what? In pH when small acid or small base is being added to what? To heat is called buffer solution. Then let us look at what? The types of buffer solution. So normally there are two types of buffer solution. The first one we have what we call what? Acid buffer, and we also have basic buffer. So let's take it one after the what? Other. What is acid buffer? And then what is what? Base buffer. Right? The acidic buffer, the first one, starts from what? So the acid buffer is consists of weak acid and the salt of that same what? Weak acid. So acid buffer is a buffer solution that is contain the what? The weak acid and salt of that what? That weak acid. We always use what? Weak acid and a weak base for what? For the buffer what? Solution. I will explain the reason before the end of the what? Class. So the acid buffer comprised of the what? Weak acid and salt of that same what? Weak acid. So you can now say what? These contain weak, this contain a weak acid and salt of the same weak acid. Take for example of what? Acidic is we have ethanoic acid, ethanoic acid and sodium ethanoate. Look at what? The ethanoic acid is a what? Is a weak acid. And the salt is also what? Weak salt or a salt of the weak acid. Let me put it here for the convenience sake. The formula. This ethanoic acid is what? CH3 COOH The salt will be what? CH3, COO, sodium. Now we can also have what? Hydrogen carbonate, H2CO3. So this H2 to CO3 is a weak acid and its salt is what? Potassium carbon what? Carbonate. So this is also a what? A buffer. And we can also have what? Let me add this to it. The third one, we can also have hydrogen cyanide. Hydrogen cyanide I gave you yesterday in my previous video, that is a weak acid and its salt is what? You can use what? Sodium cyanide. So, and so on. So these are the what? The three example of what? Of acid buffer roots, but they are more than what? More than this. So the acidic buffer contains what? Weak acid and salt of that same weak acid. This here now, we have ethanoic acid. What is this salt? Sodium ethanoate. Hydrogen carbonate acid, we have what? Sodium carbonate. Hydrogen cyanide acid and what? Sodium cyanide. The next thing is what? The calculation on pH of acid buffer. Calculation on the what? pH of what? Acid what? Buffer. Mhm. Okay. Calculation on pH on acid buffer. Calculation on pH of acid of an acid and acid what? Buffer. Let's consider this first example of what? Of buffer solution, acidic solution, which is what? Ethanoic what? Acid. So we said ethanoic acid, CH3, COH is ionized to give us what? CH3, COO minus plus H plus. This is in aqueous. We also have this in aqueous. We also have it in what? In aqueous. This ethanoic acid, this is what? A weak acid. This ion, it is what? Salt. Because the sodium metal, it will later react with what? With this to form what? Sodium ethanoate. So from this expression, let us write out the what? The equilibrium constant. So the Ka, the equilibrium constant for this reaction, it will be concentration of what? CH3, CO minus, and a conc of what? H plus, everything over what? The conc of reactant, which is what? CH3, COO what? H. So from this expression, we are looking for the what? The pH of acidic buffer. And then we know that what this pH simply means with the power of hydrogen. In this equation now, we have Ka ethanoic ion, ethanoic acid, hydrogen here. we need to make what this hydrogen ion as a sort of formula because it's our major interest here. We are looking for the pH and the power of hydrogen. Take this hydrogen as the what? Subject of the what? Of equation. By doing that, I think we have what? By doing that, making hydrogen, we have hydrogen plus should be equal to Ka into what? CH3 OOH, everything over what? CH3 CO minus. Check it. By making the formula, this is what you are going to what? To arrive to. So at this level now, the next thing that we do now is what? You will take logarithm of what? Of both sides. Let what? Take what? Take, let's take negative logarithm of both sides to what? Of both sides, negative logarithm of both to the extent of both sides. Let us introduce what? Negative logarithm to this. By introduce negative logarithm, we are going to what? To arrive to what? This will be what? Minus logarithm of conc of h to base 10 equal to the what? Minus conc of what? K to what? To base 10. Here, apply the law of logarithm. We split it minus logarithm of what? Conc CH3 COH to what? CH3 COO minus. Good. This, if you put logarithm here, this multiplication, abi, you can split it to become addition. When it become addition, then logarithm will enter. So this is what we have. It's not like magical. The next thing is what? You can now say what? Recall that pH is equal to the minus logarithm of conc of hydrogen ion to base 10 and pK is also equal to the what? Minus logarithm to base 10 of K. So we can substitute for pH here and substitute for what? For pK here. Then we are going to arrive to what? We are going to arrive to what? What is it? Yeah, put there. We now have what? pH is equal to what? Instead of minus log Ka base 10, what is our Ka? Log Ka is pK plus pK minus logarithm of CH3 COOH into the what? CH3 CO minus into what? Base 10. And don't forget that, you know, I'm using ethanoic acid here, abi, and it's salt. You may give any acid, any weak acid and it's salt. So for the convenience sake, you know, I put acid here and I put salt here. So let me change it back to the what? Original. Well, you can now have pH to be equal to what? pK minus negative logarithm of What do we have here now? This ethanoic acid is acid. You can now write what? Of what? Sorry. Add what? Acid. Then here you can write what? Correlation of what? Of salts. So this is how we can calculate the pH of a bubble solution. So this is the formula for pH of bubble what? Solution. But in one condition again, if concentration of acid is equal to what? Conc of what? Of salt. What do we have next? We have what? P what? pH equal to the what? P minus logarithm of what? Sorry. If this what? Conc of this and conc of this are equal, everything you have here is equal to the what? 0. Therefore, the therefore, what will happen there? P what? Therefore, pH will equal to what? pKa. So that is what? The rules. So the next thing is what? Let's look at what? The basic bubble solution. So the basic bubble solution is almost or the same with what acidic bubble solution. This is also contain a weak base and salt of what? That same weak base. So this contain a weak base and salt of the same weak base. Yeah, for example, of basic bubble solution. So, example here, you can have what? Ammonium oxide is a base and ammonium chloride. Yes. We can also have what? Ammonium oxide, hydroxide, and ammonium sulfate. So these are the two common example of basic bubble solution. So it's a solution that contains weak base and it's salt of the same base. Then let us look at what the calculation of what? Calculation, calculation on pH of basic buffer. So, please, for the convenience sake, follow the same what procedure with what? With the acid. So in order to what? To save our time, if you want to write this for base now, you can write the, let me write the equation down, then I will move to the short cut straight. We have ammonium, let me put ammonia dissolved in what? In water to give us what? NH4OH. So ammonium plus OH. So you will now write out the what? The equilibrium constant for these two. This is the same thing as what? This is a base. This one is what we call what? It's salt. So by writing out the what? The equilibrium what? Constant. The KB, it will be what? Conc of what? NH4 plus OH minus everything over what? Conc of what? NH3. This one will be 1. So we have this. So if you now what? Solve it further by follow what? The same procedure with this, we will arrive to the what? To the same answer here. So in order to want to save the time, what are we going to arrive to? We now have what? P what? OH equal to what? PKB minus logarithm of what? Conc of base over what? Conc of what? Of its salt. So this is what we are going to what? Arrive to. But if it's the same like acid, if what? The conc of acid, sorry, if the conc of what? Of base is equal to conc of salt, what are you going to arrive to? Therefore, the pH is equal to what? pKb. So that is all about what? The pH of what? Of the bubble solution in acid and a what? And a basic. And I forgot to give example of what? Of bubble solution. See, we have example of bubble solution. Example, we have EG, we have human what? Human blood. And we also have what? Sample. The sample that we lady use to what? To wash our what? Our hair is also a bubble what? Solution. The baby body lotion that we use to cream our baby is also what? A bubble what? Solution. So those are the 3 common examples of what? Of bubble solution. But the common one and the easiest one is what? Is blood. Look at what? The pH of blood is 7.4. If you use any drug that is acidic, or you eat anything that is acidic, when you get to the blood like this, the pH of the blood is still what? It still remain. If the drug you use is what? Is basic, or the food you eat is basic, when you get into the blood is what? It cannot change the what? The pH of the what? Of the blood. So the common example of the what? Of the bubble solution, we have human what? Human blood. So no matter how the drug you use or the food you eat, they cannot change the what? The pH of what? Of the blood. So the blood have the power to resist in changing what? In pH and color when small acid or base is being added to what? To heat. That is all about what? Buffer solution. But let us solve for 2 or more questions on this. How to use this formula before we move to the next aspect. So solution. So look at this question. Calculate the pH of the buffer solution containing 0.04 molar. That's molarity of ammonium chloride. And then we also have what? 0.02 molarity of what? Of ammonium hydroxide. And Kb is what? Of ammonium hydroxide is this. So we are given the what? The Kb. Let me say no concentration of, let me start from here. Ammonium chloride NH4Cl is concentration is what? 0.04. And the concentration of base is what? Is 0.02 molarity. Then we have K what? Kb as what? 1.8 times 10 raised to power minus 5. We are now asked to find the what? The pH. So what is the formula for pH? We are looking for what? Don't forget, we are looking for P what? pH. But before we go to pH, and then we are getting base. Abi? So before you know the pH, you must first of all find what? pOH, because we are given what? Base. So if they are given acid, you use the pH directly. Yeah, what is the pH? That's what? Using pOH will be equal to the what? pKb minus logarithm of what? Conc of base over conc of what? Of salt. This Kb is unknown. Let's find the Kb first. pKb equal to the minus logarithm of what? Of Kb to base 10, which is equal to the what? Minus logarithm of, what do we have here? 1.8 times 10 raised to power minus 5. By pressing the calculator, this one we go here, become plus logarithm of what? Of 1.8 raised to power, this will give us what? 4.7447. That will be the what? The pH for what? For P, the value for pKb. We'll now put it here. So let's go. Let's solve for this now. Yeah, we now have what? P what? pOH should be what? The value you have here, 4.744 minus logarithm of, what is the concentration of the base given? The base is 0.2. We have what? 0.2 as the base. For the what? Salt, we have for 0. What? 0 point what? This. If you press this now, you press this, it will give us what? Press the value you get here. All together, calculator. Yes, so if you press the calculator, we have what? 5.0457. That will be the what? The pH, pOH of the what? Of the base, of the buffer. So you can now say what? Recall that from pH plus pOH it's equal to the what? 14. So from this expression now, the pH is equal to what? 14 minus pOH. So you now have pH should be 14 minus 5.04545.7. So final answer, the pH will now give us what? 8.354. That's what? The pH of the what? Of the buffer solution. See, if you are given any question in this format, this is how we what? We will solve it. And at times, if they give it for acid, you apply the formula for acid to get your what? Your final answer. Let's solve this second example too. Look at the what? The first one is based on what? On a base. This one is what? Is an acidic buffer. Let us look at it now. Solution. If we have a question like this, we are given the mass of acetic acid and the mass of what? Of sodium acetate. Look at here. For base, they gave us the what? The molarity of both base and a salt. But here we are given what? Mass of the two, acid and the what? And the salt. So we are going to convert what? This mass into the what? Into the molarity. So, and we are given what? This again, Ka. And the formula used is what? To know the pH. We all know that pH is equal to what? pKa plus logarithm of what? Concentration of salt over the concentration of what? Of acid. So first of all, let's find the what? The P what? pKa. The pK, they give us Ka. pH for pKa is negative logarithm of pKa. We are given Ka to be this. So logarithm of 1.8 times 10 raised to the power minus 5. So into the what? Base 10. By pressing the what? The I put pH is pK. So P what? K. Press it. The final answer that we have by pressing logarithm of this, we have done it before here. We get what? 4.7447. That's what? pK. A. And the next thing is what? Let us find the what? The molarity of salt and what? And acid. So by finding the molarity of salt, the salt conc of what? Let me just write. Molarity of salt, it will be conc of what? Molarity of salt to be mass given over molar what? Molar mass. Please, what is the salt given here? Our salt is acetic what? Acid. Let us find the molar mass for this acetic what? Acid. The molar mass for acetic acid, molar what? Let me use another marker for it. For clarity, molar what? Molar mass for acetic what? Acid is, here we have for this one, for salt, or molar mark for salt is sodium ethernate, molar mass of memory to full CH3 COO Na. So carbon is 12 plus hydrogen 3. 3 times 1, we are getting is 1. It gives us dot plus 3 plus this carbon is also what? We are given that carbon is 12. Oxygen is 16. 16 times 2 is 30 what? 32 plus what? 32. Which else again? Plus sodium. What is sodium? Sodium is what? Is 23. Is 2 what? 2, 3. If we add everything together, the molar what? Mass of CH3 COO sodium ethernate, it will now be equal to what? 100 and what? And 36. Yes. And the next thing is what? We are looking for the what? Oh, sorry. So you now take this into what? To this side. What are we going to have now? We have what? Salt is what is mass of salt given is 1 point what? 1.3 over what? 3, 3. It will give us what? 9.559. 9.559 mole per dm or gram per what? Per dm cube. Or you can put what? The molarity in M. So this is what? Of this. And the next one is, let us find the what? That of what? Acid. So to know the acid only be what? Form of acid, it should be what? Mass over what? Given mass over molar mass. So the given mass for acid, this is the given mass for acid, given mass for acid. So acid is what? Is 3 grams. What is the molar mass for acid? So it's the same thing with what? With this one. You can say what? The molar mass for acid, more what? Molar mass of CH3 COOH will be equal to what? 12 plus 3 plus 12 plus 32 plus 1. It will give us what? 33. But 33 minus 22 you get what? 110. We now have what? Molar mass of acid. Am I getting it? 60. So everything we have here is what? 60. But there is a little mistake here, and I have corrected it. So the molar mass of this is not 133, it's 83. Divided by this, we have this. So, yeah, we now substitute for what? For acid. So the count of acid now, it will now be what? 1.3 over what? Sorry, mass of acid is 3. 3 over 60. So by dividing 3 over 60, we have 0.05 molarity. So this is for acid. And the next thing is what? Let us apply our formula for P what? For pH. Where pH is always what? pH is pKa plus logarithm of concentration of what? Of salt over conc of what? Of acid. So by applying this now, We have pH should be, what is pK you get is 4.744 plus logarithm of what? Concentration of salt. The salt we get is what? 0.0156 for salt over concentration of acid is 0.05. Everything into what? Base what? Base 10. Please let us press the calculator to get the what? The final answer you get here, you press the calculator, add it with what? With this. So it should be the what? The final what? Answer. So with this, that is all about what? The Bova solution. And the next aspect, which should be the last aspect of acid-base concept, is acid-base titration. Let us look at what? How you can titrate acid-base and what? Acid-base titration. By using titration to determine the unknown concentration with the aid of what? Of known concentration, which is known as what? Standard solution or titrant. So